Righty ho. I love that expression. Right, we're doing esters now. They have the functional group COO, which is a H away from carboxylic acids. If you haven't seen alcohols and what's the other one? Carboxylic acids. I can't even remember them. I'm doing the videos on. Yeah, so if you haven't seen them, I'd go check those out before you do this one, because this one sort of combines the last two to make something magical. But yeah, I'd go for those two first. Right, unless you know it already. I mean, unless you've gone through the book and shit. But bad language. Apologise, children out there. Sorry, I am actually still a child anyway. Anyway. Esters have the functional group COO. They form when an alcohol and a carboxylic acid come together and merge. Right, an acid catalyst is usually used, for example, concentrated sulfuric acid. So an alcohol plus your carboxylic acid gets you to an ester and water. God, it's windy out here. An ester and water. I'm sure it's going to be an example here. Oh, yep, there we go. Right. Right, let's think of an example. Okay. Okay, so methanol plus propanoic acid. So you got your alcohol in methanol, and you got your carboxylic acid in your propanoic acid. Just go back to the last couple of videos if you don't know. You get to your ester. Now the ester will be methyl from the alcohol, propanoate from the carboxylic acid, and you also get water as well with that. I apologise for the sheets flying off behind you. No, over by you somewhere. Look, behind you. Behind you, there's sheets flying everywhere because it's windy. You're like there. Ooh. Anyway, so methanol plus propanoic acid gets you to methyl propanoate and water. So your alcohol plus your carboxylic acid gets you to your ester and your water. Bit of a complex name there, but you know, methyl propanoate. Another example would be ethanol plus ethanoic acid gets you to ethyl ethanoate and water. So you could have propanol plus ethanoic acid, which will get you to prepyl, ethanol, methanol, propanol. So it'll get you to propyl, propyl ethanoate and water. And if you had methanol and ethanoic acid, it would get you to methyl ethanoate and water. If you had methanol and ethanoic acid, no, I just did that one. If you had ethanol and methanoic acid, it would get you to ethyl methanoate and water. I know they're complex. I'm struggling myself, and I'm no genius. So the alcohol forms the first part of the ester's name, and the acid forms the second part. Right. So that's all you need to know about how you're forming them. That's it. You just need to know how to form them. You don't need to know any other, by the looks for any other chemical reactions. That's the only one you know. Unlike alcohols, where you have to know how they burn, and that they dissolve in water to produce neutral solutions, and that they react with, what's the other one? They react with something else. Oh yeah, you can go back in a previous video for that. And carboxylic acids, where they also do other reactions, and you also know how that works, how they're made. With this, you only need to know how they're made. So it's the alcohol and the carboxylic acid get you to your ester and the water. Vital. Learn it. Do it now. So, time for some properties and some things that they're used for. So, they smell nice. Whoop-de-doo. They have a pleasant smell, often quite sweet and fruity. But they're also volatile. This makes them ideal for perfumes, because the evaporated molecules can be detected by smell receptors in your nose. Okay, so volatile, I'm guessing, means that they can evaporate easily. So they can be used in perfumes because they evaporate lots, and you'll smell the evaporation. And because we've just discussed that they smell nice, because they evaporate a lot because they're volatile, and they smell nice, they're going to be used in perfumes because you can smell the nice thing. Makes sense. To me anyway. If it doesn't, leave a comment and I don't know, I'll probably get back to you. Might not. Busy time. Anyway. Many esters are flammable, or even highly flammable, so their volatility also makes them potentially dangerous. So they're very flammable, so I'm not entirely sure why they're being used in mass-made products like perfumes, but that's what they says here. So, another key feature that they could ask you to compare with carboxylic acids and alcohols, they could ask you to compare these, is how they mix with water. So what you need to know is that in a previous video I've said that alcohol mixes really well with organic solvents and also water. Carboxylic acids react really well with yes, that's right. Carboxylic acids also react really well with water. Esters don't. So alcohols and carboxylic acids react really well with water. But esters don't. But esters do mix well with alcohols and other organic solvents. Learn it. Just learn it. They mix well with alcohols and organic solvents, but they don't mix well with water. And by organic solvents, I think they might possibly mean carboxylic acids, but I'm not sure. Don't take my word on that. I'm only blonde, so anyway. So that's some things, that's some properties of them. They smell nice, they're flammable, they don't mix well with water, they do mix with alcohols and organic solvents. Some uses of them are they're used in perfumes, which we've talked about, because they're volatile and the molecules that they evaporate can be detected by the smell receptors in your nose, like in there somewhere. Anyway. They're used to make flavourings and aromas, like pear drops, for example. Love me a pear drop. Must use an ester. Some esters are used in ointments. They give deep heat, trademark, its smell. Other esters are used as solvents for paint, ink, glue, and in nail varnish remover. Okay. So, some uses of them are that they're used in perfumes, they're used for flavourings and aromas, they're used in ointments, and they're used as solvents. Some properties of them is that they smell nice, they're flammable, they don't mix well with water, and they mix well with alcohols and other organic solvents. Time for some bad stuff. Wahahaha. Anyway, ooh. Looked like I had no teeth then. Anyway, I do have teeth, I'm not Jeremy Carl. So, inhaling the fumes from some esters irritates mucous membranes in nose and mouth. So some esters, although ironically they're used in perfumes, some of them, probably not the ones that are used in perfumes, but some of them irritate the mucous membranes in your nose and mouth, and so can lead to bad things for you. Also, ester fumes are heavier than air and very flammable. So heavier than air, I'd imagine that means that they'd sink to the floor. Yeah, that makes sense, because balloons are lighter than air, so they go up. So if something's heavier than air, then it must go down. We know they're very flammable. We've talked that they're very flammable. Just use your common sense. If it says that, I don't know, if the exam question is, what happens if you lit a match near an ester? Just use common sense. I mean, you know they're flammable. You're going to get a flash fire. Flash fire, obviously. And that's just common sense. I mean, you can do that. You don't really need to know that. You just need to use this, not the sunglasses, the brain, or the hair. Just right, so some esters are toxic, especially in large doses. People worry about health problems associated with synthetic food additives such as esters. Okay, so some of them are toxic, so some people think in large quantities, so some people think that eating them in small quantities is bad for you, but obviously there's been no proof or anything, otherwise we'd not be eating them anymore. Yeah. So, but esters aren't as volatile or as toxic as some other organic solvents. They don't release nearly as much toxic fumes as some of them. In fact, esters have replaced solvents such as toluene in many paints and varnishes. Okay, so organic solvents. Organic solvents are, there's three that you have to know about. Brought someone there though. Three you have to know about: alcohols, carboxylic acids, and esters. They're not nearly as toxic. Esters aren't nearly as toxic as some others. Obviously, there's more than those three. It's not nearly as toxic as some others, and so can be used in. It can replace things in some other things. Okay, so an overview. They end in COO. Sorry, they have a functional group COO and an end in it. Well, their molecular structure ends in it to show the functional group, because you should always do it and you shouldn't group it because you have to show the functional group. And I hate chemistry so much, but I'm doing these videos because you, the people out there, also must hate chemistry so much to be on YouTube instead of doing it, which is bad. But as you hear, I'm going to give it a go. Yes. Okay, so they have the functional group COO. Their names end in 08, not 08, but like O, A, T. Anyway, there's some properties of them that they smell nice, they're flammable, they don't mix well with water, and they mix well with alcohols and other organic solvents. That's 4 properties you need to know. Right, so the things you need to know off this page, I think, are you need to be able to identify one from a picture, but that's in the book, you just got to look it up. You need to know what they end in terms of their molecular structure, but also their name. For example, COO is what they end in their molecular structure, but their names end in, well, 08. Sorry, it's a bit of a bad one, but you know, what can I do? It's on the book. You need to know 4 properties. You need to know that they are smell nice, they're flammable, they don't mix well with water, and they mix well with alcohols and other organic solvents. You need to know what they're used for. They're used as perfumes, flavourings and aromas, ointments, and solvents. 4 things you need to know for that. And then you also need to know 4 things about how they're dangerous. So, they can irritate mucous membranes, they can be very flammable, they can be toxic, but a benefit is that they are not as toxic as other ones. So that's basically it, really. Yeah, and that's the end also of Unit 1, well, 3A. So, well done to you, sir, or madam, unless you've just got onto this video, in which case that defeats the object and point, and you probably didn't understand most of that. In fact, I didn't understand most of that, but, you know, my exam's, what, Monday, and today's Saturday. Yeah. Oh well. Thank you for watching.